The thread class in Java is defined in a couple different interesting ways. Now, there's a thread class itself, but when we want to create a thread, we have to understand that a thread is an object, just like everything else in Java is. We said that in the previous one, but now we're going to get to specifics of that. A thread is an object, and you can see that from the thread class from Java, which actually extends out the object class. But the important thing about it is it implements this thing called a runnable. When a thread needs work done, remember, a thread's a script, so we need to have a specific place to define that script. And the run method we see here, public void run, is that script. It gives us the details that we're trying to get at when we're doing the threading work. So our work is defined inside of the run method, and so we just have to find a way to provide a run method. Now, within the thread class, there's also something called a start method. So if I say run, if I call the run method, that's like me hiring, $100,000 for a president to come and speak at my university, and I write a speech for them to say, and then I go up and read the speech myself. That's what the run method is. The start method is where I say, here, Mr. President, here's your speech. They hand it to them, they go up and they read it. We have to differentiate the run versus the start. The start method is what kicks off a thread. It's what sets it up as a separate thread, as a separate thread of execution inside of the Java virtual machine. That's where we may or may not be running all at once. And so we have to be really careful on which one we call and when we call it if we actually want threading behavior. So, like I was just saying there, in the Java world, if I have a main thread and I call the run method on a separate thread, then I run those steps as part of the main thread. All the work gets done without the Java runtime environment ever getting involved. Where if I call the start method from the main method, it goes to the thread. The thread goes and registers itself with the Java runtime environment, and then it calls its own run method at some other point based off the Java runtime environment's rules of that. It sets that up, the JRE that we talked about before. So it's really important that you differentiate between these two when you're going to get to the thread. In the work that we're going to do, you probably wouldn't even notice necessarily if you did this wrong. It would probably work mostly the same way, but in the test stuff that we'll play with, you can see the difference, very, very clearly. The work we have, the assignment, doesn't really require too much for threading, but we'll see that a little bit. So let's walk through the life cycle of a thread in code here. So I'm going to create a counter thread. We're going to come back to the exact full definition of this as we go, but the counting thread here, its job is going to count 1, 2, 3, 4, 5, things like that. So I have my counting thread, and I create a reference to it, just like any other object. I have a reference to it. I can pass it along. I can do whatever I want to with that reference. And then I create an instance of my counting thread, which is the object. It's not a thread yet. It's not running as a thread yet. It's an object that has the potential to be a thread. And then what I call start, that's where the thread gets kicked up off as an object. And then the run method is called separately. We don't call the run method, we call the start method. And you can see the run method inside of there counts for I is equal to 1, less than 100, I plus plus, go print out. So it goes 1, 2, 3, 4, 5, all the way up to 100. When it gets to the end of that, when it gets to 100, the thread stops execution. And then it's done. It's over with. I can go call run method separately. I can call run method while it's running, but it can never be a thread again. If I try call start on that thread again, it'll say, I'm sorry, I've done my work. It's kind of like trying to, ask a dead person to vote. In Chicago, you can try it, but you're not supposed to. It's not going to work, and the rules are going to say, hey, you can't do that anymore. All right, so the way we can have that happen, there's two ways we can have that happen. One of the ways is I can extend out the thread object. So the thread object is obviously what we have. It's extension from object. And by extending out the thread object and replacing the run method of that thread object, I become a thread on my own. And I'm creating my own type of thread at this point. If you remember inheritance, the definition of inheritance is when I extend something, I'm a type of. So I'm a type of thread. So I'm a thread that does counting. Now, the key of this is I have to replace the run method. If I don't, then I have a thread that does nothing. When I kick off my thread, it calls run. The run method by default, it's there, but it's empty, and so it does nothing and it's over with. So by putting my own run method out there, it gives me the feel of, hey, this is the behavior I want to have happen. You can see run, I my for loop counting 1 to 100. Now, the issue here is because of inheritance rules in Java, I can only inherit from one class at a time. So I could have a class out there that already knows how to count. It already knows how to go 1 to 100. Maybe it has some other features, like maybe I don't want to do 1 to 100. Maybe I want to 1 to X or X to Y or whatever like that. It has super great behavior out there. Well, if I extend out thread class, I can't be a thread and a counter. There's no rule in Java that allows me to do multiple inheritance. So I can't be a type of thread and be a type of a counter at the same time. So the way around that, as we saw before, is the runnable interface. Even the thread implements the runnable interface. A runnable interface is basically any class that has a run method with no parameters in and returns nothing back. Very simple method right there. The thread class can be created where it externalizes the run method. So it basically allows us to hand us the script for what work is going to happen. So in the runnable class here, I can implement the runnable class in my counting thread instead of extending out thread, and that gives me the benefit of being able to take any behavior that's ahead of time. And more important, I don't confuse the issue by being a type of thread. Oh, sure, I do threading, but I'm not a type of thread. Just because I pick up an instrument doesn't mean I'm a new type of musician. I'm just a guy who plays an instrument, right? So the runnable interface, as we said, very simple. It has the run method with no parameters in, no return type out. There's no way to pass the data into a thread via the run call. There's no way to get data out of a thread via the run call. There are other ways to do it. It's just not going to happen via the run method. As long as a class implements runnable and has a run method, it can be handed to a thread as a set of work to be done. So the counter to that is building a runnable class. Is I can have any class that extends something or not, but implements runnable. And in this case, you can see I have the same run method I saw before. There's not a huge preference. I mean, a rule of thumb, just from cleanliness and preferred standpoint, is this is the better way to implement a thread. You only need to extend a thread if you're changing basic threading behavior, because that gives you the most flexibility to be able to extend something later on or something along those lines. But this is the preferred way to make it, but either way is acceptable, certainly for this class. So the difference is now when I build my counting thread, I have to add one more step where I have to create a thread object. You see thread T inside of here. And thread T is a new thread where I pass in the counter to that new thread. I'm giving this instruction set. Then I go and start that thread. So I have one additional object I'm creating along the lines of the path to create the thread. But now I have a reusable object, the counting thread, that I can use in different interesting contexts. I don't have to be stuck extending the thread out. So in general, you should extend a thread when you're creating a new class that you're going to probably extend out in other ways. You're going to use in other ways. If you want to have a thread that every time it reaches the end of the run method, I want to send out an alert to somebody else saying, hey, the thread has stopped running, then build a new thread class. Some customized behavior on threading. If all you're trying to do is add the run method inside of here, the preferred way is to implement the runnable. And there's pretty simple ways of doing either one of these. Like I said, it's not vital you choose one or the other. It's just stylistically preferred to do the runnable. All right, so this is the foundations for threading. We'll see some of this basic threading in action inside of our coding instead of a demo here. Later on, we'll actually add threading into the project we have started, into the client-server project. But I encourage you to play with threading on its own. Look at these demos and play with threading on its own before you dive into adding it to the whole project, so you have a good idea of the capabilities of threading separate from what we need to do for class.